We're going to switch gears a little bit. We're going to talk about some volumes and surface areas for a while. We may come back to micrometers and calipers next week, depending on the results of the quiz, just because it's often, take a little break and come back to it, so it helps it kind of cement into you. And that is one that's kind of important for you guys. In the shop, are you guys mostly using digital, or you guys said your micrometer at least is vernier? And what about your calipers? They are dial? Good. One of the things I always talk about people with is if you do use digital, because there's always, your group is actually pretty good about it, there's always one or two people in the group, I'm just going to buy a dial, I don't have to read them, or digital, so I don't have to read them. And one of the problems with digital, the newer ones, if you spend the money on them, they are more accurate. You can buy a $50 digital caliper, and you're guaranteeing yourself a life of huge errors. But if you spend the money, like $300 or more, to get a good digital caliper, they do work. The problem with them is they have to be calibrated, and they have to be calibrated correctly. Digital is set off tremendously by temperature. So they are, I believe it's 72 degrees, between 67 and 72 degrees, if I remember correctly, is where they are calibrated, set to be most accurate. So anything above or below that, it messes with their sensors and stuff that do everything. But you can still calibrate them and they still work fine. The problem is most people, they calibrate them by just closing the jaws and hitting the terry and zeroing them out. If you're measuring something 3 or 4 inches long, that's quite a ways away from where you calibrated it. So you have to calibrate it near what you are measuring. So let's say you're measuring something that's 3 or 4 inches long. You need to calibrate it close to that size, actually a little bit below that size. You guys have seen gauge blocks already, right? Okay, have you worked with them at all? Done any build-ups or anything like that? A little bit? Not really?
No. Oh, yeah.
See, if you're measuring something that's between 3 and 4 inches long, you would want to take your 3-inch gauge block and you'd want to calibrate your digital caliper at 3 inches, zero it out. Now it's going to zero now, so 3 inches is going to read as 0, but now when you go and measure whatever it is you're measuring, you just add 3 inches to it. So you know that you are more precise that way. Your calibration is close on. The further you get away from where you calibrated it, the more chance there is for error in those. So anyway, today, our new stuff, at least for our first hour here, we're going to be talking about volumes and surface areas again. And we've already looked at boxes. Volume we've described as being the area of a base times the height. So what do we mean by area of a base? Well, on this box, actually any side of this box could be a base, so we generally go with the bottom as the base, because we think of the base as being at the bottom of an object. The base, however, does not have to be the bottom. The base is the shape that the object is based, that was used to create the object. So one way to think of it is if you grab onto the base, you should be able to slide it through the object, which for a box like this, any side, you can grab onto it and slide it through the object. So anyway, for the first step in finding our volume is to find the area of that base. So if we fill in some dimensions here, let's give you 12 inches, 10 inches, and 7 inches. The area of the base is 12 inches by 10 inches. So 10 times 12 is 120 square inches. So then my volume is found by taking that area of that base, 120 square inches, times that height is 7 inches. So 120 times 7 is 840. Inches squared times inches is inches cubed. Now, that's our total volume. Surface area is the area of all the surfaces. Well, I've got the area of the base. I already found that as part of my volume. And there are two bases. So the 120 square inches is going to play into this twice. So that gives me the bottom and the top. So now we got to find the sides. There is a special name for the sides, and that is called lateral area, or lateral surfaces sometimes. The lateral surfaces are the surfaces that connect the bases. So they said the base, we got the base on the bottom, the top is identical, so that's also the base. The lateral area, the lateral surfaces, are these rectangles on the sides that connect the two bases. To find the area of those lateral surfaces, to find the lateral area, we could find each of the individual pieces, or we could cut it and roll it out. If I roll out all those rectangles to make one big rectangle, so I cut it up this corner here, and I roll it up to make one big rectangle. The height of this rectangle is still 7 inches. Still just the height of the box, right? But the length of the rectangle is cut into pieces. 12 inches, 10 inches, 12 inches, and 10 inches, right? So I'd add those up to get the length of that box, which is going to be how much? 44 inches. Well, that 44 inches, if I look back at my original picture here, is just this plus this plus this plus this. What is that describing to me? The perimeter. Yeah, it's the perimeter of the base. So the lateral area, or lateral surface area, sometimes called, is just the perimeter of the base times the height. So now you got to be careful here. Volume was the area of the base times the height. Lateral surface area is the perimeter of the base times the height. So the perimeter of the base is 44 inches. The height is 7 inches. That is what, 308 inches squared? I believe so. We add those up, we get 548 square inches. That is our total surface area. Area of the base, and then the lateral area. So that total surface area is the area of the bases plus the lateral area. Now you might be looking at this thinking, I really made that way more difficult than it had to be. I mean, we've always been told volume for a box is length times width times height, right? Which is true. But the length times width is just the area of our base. And the surface areas, I could have just found all 6 of the rectangles and added them together. Again, that's true. The reason I defined my volume this way, and my lateral area and total surface area the way I did, is because we could run into problems like this. So that was my volume. That was the end of that. That's the volume. I'm done there. So at that point, then I switched over to finding surface area.
And so why, 120 is just the base?
Area of the base. That's just this. Yep.
You just take the area of the base
times the height. Get volume.
You take the area of the base base twice.
For surface area, yeah, you add the area of the base in twice.
So what is the lateral area again?
Lateral area is the area of these sides that connect the two bases. So here, find volume and surface area. If I'm looking for a base, the base is definitely not the bottom of this. Can I grab onto the bottom of this and pull it through the object? No, I cannot. What shape here can I grab onto and pull through the object? This triangle. This triangle is the shape that was used to create this object. Think about the base is the shape that if you took a bunch of pieces of paper and cut them out that shape and you stacked them up, you would create the object. Does that make sense? If I took a bunch of these triangles and I just stacked them up, I would create this object by stacking up those triangles. So that triangle is the base. So, what do we do with it? For finding volume, our first step is to find the area of the base. And this will be 8 inches times 6 inches divided by 2 because this is a triangle. So that'll be 24 square inches. Then what's step 2? Step 2 is to find the volume. Take the area of the base times the height. So 24 square inches times 15 inches. Now it's a little weird because we're used to that height being up and down, but the height is just the distance between the bases. That's going to be 360 inches cubed. Now I'm going to pause it. Any questions on how we found that volume? You found the area of the base, which is the highlighted triangle. Then we just stacked them up. We multiplied that area by the height. So now for surface area, we're making, so this is a total switch of gears. We're starting over on a new calculation here. Find surface area, it's the area of the bases plus the lateral area. Well, we already know the area of the base, right? 24. So we've got 24 square inches plus another 24 square inches. There's one on top. Now, once again here for the lateral area is the area of these rectangles that connect the two bases. So I've got that rectangle down there. I've got this rectangle here. And I've got this rectangle here. I could just find the area of those 3 rectangles and add them together. But there's an easier way of going about it, which is to do it all at once. And the way I do it all at once was I think about taking those and cutting them and rolling them out. If I roll those out, I'm going to get a rectangle again, a big rectangle. This is still 15 inches. That's still just the distance from here to here, right? The length of this rectangle, this dimension, is going to be the distance around the base. In other words, the perimeter of the base. Does that make sense? So that's the perimeter of the base. How do I find the perimeter of the base? Easiest way is just to add them up, right? So I've got the perimeter of the base is going to be 6 inches plus 8 inches plus we got to do a little work, right? That's a right triangle. Right triangle has 2 legs and a hypotenuse. 6 and 8 are what? They're both legs. So that means it's going to be 6 squared plus 8 squared equals, the hypotenuse is labeled as c, so that'd be c squared. So 6 squared is 36, 8 squared is 64. That adds up to 100. Square root that. It's going to be 10. So that's 10 inches. So that perimeter is 6 plus 8 plus 10. This is a perimeter of 24 inches. So the lateral area is the perimeter of the base times the height. So that is the 24 inches is the perimeter of my base times my height of 15 inches, which is going to be 360 square inches. So I add that to my 2 bases, get 408 square inches is my total surface area. Any questions? Oh yeah, we're going to do more. In fact, you guys might do some more. Let's have you guys do find the volume and surface area there, correct? So here for volume, what's my first step? Find the area of my base, which will be 5 inches times 12 inches divided by 2. So it's 30 inches squared. What's my next step? Yeah, volume is the area of my base, 30 square inches times the 20 inches of height, which is 600 cubic inches. So that's it for volume. Done with the volume. Next step, surface area. Surface area is the area of the bases, so I've got 30 plus 30 plus need my lateral area, right? So to find my lateral area, I first need to find the perimeter of my base. What's the perimeter of my base? Well, it's 5 plus 12 plus, I've got to find this side here, don't I? 5 and 12 are both legs, so it's 5 squared plus 12 squared equals c squared. C comes out to be 13. So 13 goes in here, we add that up. That adds up to 30 inches of perimeter. So my lateral area is my perimeter of 30 inches times, was that 20 inches, sorry. 20 inches of height equals 600 square inches of lateral area. Adding those all up gives me total surface area of 660. What do you think? Okay, it's time for break, so let's do that.